Okay, another video. Today we are going to bring copper as a big topic on our energy series. So we are going to talk about copper and how it's a problematic to the wind, solar, battery proponents and all the ESG pin counters that they are completely out of touch because from copper a lot of the hopes of the so-called renewable energy equipment come. So don't forget to subscribe and then we'll start. So we gotta give credit to B.F. Randall. He's a lawyer and a nuclear power proponent. He also is a big guy in mining. So I'm posting his account and his thread from his Twitter account on this video to give him full credit of his thoughts. And I thought it was very interesting the analysis he did. So civilization's very first metal was copper, right? It eventually surpassed in importance by iron and steel, but that's later. But at the beginning, Edison and Tesla, world demand for copper became nearly infinite. So Butte in Montana held the world's highest grade copper resources, and the whole world came to Butte to mine copper because copper was providing all the resources for the industrialization of the country. So several lines of his family came all the way from Croatia, North Carolina to mine copper. So when a material, a commodity lasts for so long, for so many centuries, and we still consider it important, then there must be something that makes it special. And then we have to understand how we get it. Because if solar and wind turbines need copper, we need to understand also how to get copper, how to see if environmentally speaking, environmentally friendly mining copper makes sense, right? So the so-called energy transition is a copper monster, right? Because the resultant demand for copper far exceeds anything from the world has seen before. And even during the electrification heyday, which is when we got electrification around 1870s, when we start finally getting cities electrified, Paris, and so forth. So, for instance, a 3 MW wind turbine, so a megawatt wind turbine, contains up to 4.7 tons of copper onshore. Wind farms use approximately 3.8 tons of copper per megawatt, and offshore wind farms use over 21,000 pounds per megawatt, so around 10.5 tons per megawatt nameplate. That's an extremely big amount of copper just to generate what? Some megabytes, 3 at maximum. So, and solar power systems use about 5.5 tons of copper per megawatt. So heat exchanges of solar plus wiring and cabling that transmit the electricity in the PV cell. So 266 gigawatts of new solar installations between 2018 and 2017. So in North America alone, so in the next 5 years, will be around 1.9 billion pounds of copper. That's too much. But the new demand of copper is driven by far more than wind turbines. So let's walk through a high-level, simplified explanation of how we get that copper. How is it required? First, let's start. So copper mining starts with drilling, right? Drill rings run on diesel fuel. Fossil fuel, right? And they burn a lot. So in copper mines, fleets of drills run in shifts, often 24/7, right? You cannot stop. The drills require tires, lubricating oil, grease, dust control system, and sophisticated electronics maintenance, all from fossil fuels. And the strip ratio means that the number of waste rock benches that need to be drilled, blasted, loaded, hauled, and dumped compared to the number of ore benches the stripping will open up. So strip ratios vary widely from mine to mine, right? Chile has one of the best mining systems. And the strip can be as high as 15:5:1. So basically, good strip ratios are around 2:1, which is very efficient, right? But usually the average is 15:5:1. So it's how much waste rock, how much of the product we don't need gets wasted, and how much we actually get. So the lower, the better. So the strip ratio at volcanic massive sulfide deposits like the QAC are usually above 5.1. So, and that means a lot of tungsten oxide drills bits. The life cycle assessments for tungsten oxide production is not pretty. It's mostly made in China, which is home of hundreds of thousands of coal power plants. So larger patterns usually work for waste, but ore needs crushing, so drill patterns are tighter. And regardless, copper mining means drilling lots of holes through hard rock, and it can take weeks or months to drill out a single bench, which is a defined block in the pit. And then comes the fun part, blasting. So we need ammonium nitrate. Fuel oil is the primary blasting agent, right? It's a 94% ammonium nitrate with diesel fuel oil, which is manufacturing from methane and requires a great deal of fossil fuel energy and associated emissions. So far, only the drilling and the blasting requires fossil fuels. And it's not coincidental that the Nobel Prize carries that name, right? Alfred Nobel's weird trick, which is dynamite. Because of dynamite, altered the course of humanity in countless ways, from war to the petrochemical industry to mining. So after blasting, all shot material, which is the waste, or what we call the ore, has to be loaded into a haul of trucks and moved out of the pit, right? We just not bring all the manufacturing site and you start building the turbines. No, we have to move it. So waste is dumped, ore is loaded into the crusher, and it's impossible to quantify the net fossil fuel resources consumed up to this step. This scale is enormous, right? We have done drilling, blasting, and now we have to load and move the waste. So that's an extreme amount of resources needed. And each tire of these 1,200 pounds of these trucks is around 12,000 pounds and is made with nearly 100% petrochemical feedstock, so hundreds of ingredients and 100% fossil fuel energy. So tires are not recyclable and they don't last that long. So, and some copper mines have their own tire landfill because they're so big you cannot use them anywhere. So still, to manufacture the equipment, what do we need? We need tires, lubricating oil, grease, fuel, maintenance, batteries. We're still moving things around the world, right? We need to import in trucks from South Korea, mobilization, demobilization, 100% consumption just to drill, blast, pick up, and move rock. So far, right? We haven't even gotten to the actual material. And ore has to be crushed. The scale of this equipment is hard to describe. The fossil fuels and other inputs that went into the single crusher is one copper mine, and associated carbon dioxide and other impacts, much less the power to run it, are enormous. Constant maintenance and replacement. So one of these trucks that are in the mines consume around 92 gallons of diesel fuel every hour, whether they're moving or not. And most mines, they have a fleet running 24/7 and 365. And then comes the actual part, right? The milling and the grinding. So sulfide ore is hard and must be milled down to a fine sand. Each ball mill is rated in thousands of horsepower. So a single ball mill is around 16,000 horsepower. Can mill ore with weather power. So mill operates also 24/7, 365. And so we aren't even close to be done. After milling and grinding, the ore must be concentrated and tailings floated. So this requires pumping millions of gallons of water, slurry many miles, require enormous quantities of dependable energy, which require coal or gas. And tailings are concentrated waste, right? The tailing ponds are enormous. Its construction today has required moving billions of tons of soil, rock, clay, and engineering cover. So tens of millions of tons of processing, wash, screen, and imported sand and gravel, which also require fossil fuels to be moved, right? So it's been possible to quantify the true fossil fuel requirements associated just with this one impoundment, its construction, maintenance, and reclamation. We don't know for years yet its final size and the configuration of all these places, right? So reclamation is in decades in the future. And concentrates are smelted using coal. No other fuel will do it. So sulfide ore is high in sulfur, making it an important sulfuric acid producer. So acid is sold for mining, other copper and uranium, making phosphorus fertilizer and other processors. So the ore is sulfide, so no, but the ore at the mine I help manage, BF Randall says, is heap leach very efficiently using acid derivative sulfide ore. So industrial operations are efficient and symbolic, as we see in this picture. So during smelting, the concentrates turn to lava and self-separate based on elemental specific gravity. Silica sand and other fluxic materials form a froth at the top and are tapped and removed to form slag. Metal values from the smelter are then removed, and then we still have ways to go. We need to purify and separate the smelted metals and other valuable byproducts by many more steps. So volumes are being written about all of this. So the whole video is an extreme oversimplification. I will challenge every ESG proponent and any renewable energy proponent to go and encourage the whole process. So for copper, we need electrowinning, right? Metal values are dissolved and then platted out to form cathode plates. This step consumes vast quantities of electrical energy, right? And to be sure, because it is cheap, plants often require wind, solar power, right? So the fact that mining companies use low shielding agreements to soak up excess garbage power is not a compliment. It's because the value of wind to solar to the grid is so low that utilities have to pay to get rid of it. So it's more like a hurdle than actually a help. So the end result of the entire mining process is the new catalog copper that we can see. I directly challenge all the analysts calculating life cycle impacts of wind, solar, batteries to account for the fossil fuel and carbon impacts expended in producing new cathode copper 100% consumption. Only the best high quality copper cathode meets the specs for generators like those using wind turbines. So not all of the copper that we get will be used. So the wire must be rolled in thin and long. Any imperfections in the cathode result in broken wires. So turning cathode into wire requires yet more fossil fuel energy, right? Cathode is shipped from the mine to a rod mill, sometimes thousands of miles away. At the rod mill, it's melted in an electric arc furnace, which cannot be run through solar. So that's just copper. So now if we take a look at petroleum, which we'll probably study next week, we'll see that the US wind and the US renewable energy is completely out of touch. You need so much copper, and copper needs so much fossil fuels. That is a total blast. It's a hypocritical statement to say that wind, solar, and batteries will be renewable when to create them we need the fossil fuels, the energy, the electricity. So stay in touch. We will study petroleum next week. But just to be clear, how copper needs to be mined to meet all the standards of this so-called ESG stuff. So don't forget to subscribe, and thank you for watching another episode of Meter Finance.